Hi, my name is Maria Berti and I'm a postdoc here at the University of Geneva, and I work in the groups of the professors Camille Bonvin and Kunz.
Hi Maria, so you're a physicist. Where do you come from and how did you end up here in Geneva?
Yes, I'm a physicist. I come from Trieste, which is a city in the very far northeast of Italy, where I also studied. I got there my master and bachelor degrees in physics, and then I continued with my PhD in astroparticle physics at the International School for Advanced Studies in Orsissa, which is also in Trieste. A year before defending my PhD thesis, I applied for a position here at the University of Geneva, and so I started working here a few months ago, and I'll be working here for 2 years.
Why did you choose to study science in the first place?
Well, I always had a lot of different interests and passions, so choosing for me was really difficult. When I had to choose, I was attending a school in Italy which had the focus on classical studies, so Italian, Greek and Latin literature, which I quite liked, but still I had much more fun studying math. Moreover, I was really fascinated and accustomed in a sense to the figure of the scientific researcher. First and foremost because my father is a researcher and he is a chemistry professor at the University of Trieste, but also because my city Trieste has a very rich scientific environment. A study some years ago found that Trieste is the city with the highest density of researchers, and they found that we have 35 researchers every 1,000 people, which is quite higher than the European average of 6. And moreover, there are a lot of research centers, in particular for physics, and you start visiting them already as school trips. So when I had to choose, I was a bit torn between math and humanities, but I also had a fascination for the moon and the stars, and so astrophysics was appealing too.
And then, how did you choose physics specifically?
Then it happened that I had a great math and physics teacher, and she managed to send me with another couple of students right here in Geneva to visit CERN. And it was during a period in which the collider was not operating, and so I got to see one of the big detectors. And I remember that I was completely stunned. It was fascinating and beautiful, and I remember that I thought maybe I could study physics besides the star. In the end, I realized that I enjoy using math more than math itself, and in a sense both math and humanities were too abstract for me. So physics was the perfect synthesis for me, and I got to study a lot of math, and I had to face some of the most fundamental questions of mankind. And all of this going from very practical lab exams to highly formal analysis courses. A perfect balance between theory and practice.
And was it like you expected? Did you end up studying astrophysics after all?
Well, no and no. University was not like I expected, but I think this is an experience that a lot of students share. Indeed, you are 19 and you try to make a decision with all the elements that you have at the time, but still you're taking a leap. And it was very difficult, but I liked a lot the challenge, and I discovered that physics was a very broad and heterogeneous subject, and I discovered a whole new way of thinking. I was really fascinated by particle physics, but pure particle physics was too difficult for me in the sense that it requires a way of thinking that is very far from how my mind works. I still liked astrophysics too, but it was still a bit too practical for me, and the math involved there was not always my favorite. Moreover, I also discovered the passion for programming and coding, which is something that I really didn't expect. So I found my balance again in cosmology. Cosmology is a transversal branch of physics, and it aims at studying the universe, so both how the universe is now and how it was since the very beginning of space and time. It's a fascinating topic that requires expertise from very different fields in physics. And indeed, during both my master and then my PhD in astroparticle, I got to study a bit of particle physics, a bit of astrophysics, and a lot of general relativity, which is a theory that I love because it involves very beautiful math. So looking back at my journey, it was really a matter of finding the right balance between all my interests.
So you're a cosmologist. What do you actually study?
So my expertise lies in between theory and observations. Both during my PhD and now in my postdoc, we try to investigate how present and future observations can improve our knowledge of the theory that describes the universe, its content, and its expansion. I mainly work with numerical codes that, given a set of observed data, try to find the best, the highest probable value of the parameters that describe a theory. From a theory side, we focus on models that are alternative to the standard model of cosmology, in which gravity and the component that we call dark energy are modified in the quest to find the true underlying models that best fit the data.
And what do you do on a typical workday?
So my day usually starts with planning. It can happen that I have to lead or to participate in 2 or more projects at the same time. So planning my time and setting goals is essential. Then I read my emails and answer to my messages. And another very important part of the job is to keep up with the work that other researchers are doing. So people usually put their papers on a website that it's called the archive, and so it's pretty common to check the archive daily to try to see to keep up with what other people are doing. Then, depending on the status of the project, you can either produce results or write the paper. Producing results means that I usually run tests and computations on my computer, and which I then analyze and organize in plots and pictures. Then it's really important to communicate those results to the other researchers. So what you do is you write a paper, and this paper then goes under a process of peer review and before being published on a scientific journal. Indeed, it's crucial to effectively communicate results with other researchers. So part of my day is also dedicated to meet other researchers. So I have meetings with my principal investigators, with my collaborators, or group meetings or journal clubs. It is very important also to communicate your job with other research groups. So it can happen that you have to give talks, to visit other universities, and to go to conferences. Last part of my job prescription includes teaching, which I quite love, and I found it is very instructive for me. So as you can see, you have to manage a lot of different tasks, and it can get very different from day to day.
What are the aspects that you like the most about being a postdoc? And is there something you don't like?
Well, what I like most is the thrill of being on the verge of knowledge. So I don't hide it. Maybe from day to day in your daily routine you forget about it, you lose the big picture, but ultimately this is what drives you and is exciting and fascinating. Then I like a lot that you get to meet a lot of new people, so new researchers, new groups, but also new cultures and new way of thinking, and this really enriches you deeply. From a practical point of view, I enjoy the freedom that I have in organizing my day. However, this freedom sometimes can backfire, and indeed it can happen that you are always engaged in work thoughts, so you need to find the right work-life balance. Moreover, research can be overwhelming from time to time. Indeed, it can be a very competitive environment, and you can feel a lot of pressure, especially during your PhD. So one really needs to learn how to cope with stress and pressure. But overall, I'd say that the biggest downside of being a postdoc is the instability of the position. Indeed, you go from temporary contract to temporary contract without any guarantee of landing a permanent position someday. So it can be really challenging to combine a career in academia with a family, a partner, or wanting to settle down in just one country.
What skills did you learn studying physics and doing research?
Well, I think that it's not a matter of notions, but more of that physics shapes the way you think. Actually, I think that every course of study shapes the way you think. For physics, what it gives you is that the fact that you are used to face and to solve complex problems. Specific skills may change. For example, I could be more experienced in the computational aspects, while someone else could master more advanced mathematical tools. But in the end, I think that what physics gives to you is really the ability to cope with the difficult tasks. from learning how to ask the right questions to building your own tools to solve the problem and answer these questions. I think this is a very versatile quality that could be very well exploited also in the job market outside of academia. And actually I think that studying physics could be a good idea also if you don't want to pursue a career in academia.
What important issue would you like the scientific community to discuss more?
Well, it's hard to make such a general statement, but looking at my experience, I can say that one theme for sure should be the psychological well-being of researchers, and in particular of PhD students and of early career scientists. It can be really tough sometimes, and for me definitely it was, so it's important that awareness is there and also a support system can work when needed. The second theme, which I think it's also connected, is the matter of instability. This topic, I think it's really complex because it involves money, politics, funding, and job creation. In my experience, I've seen that at some point people choose to leave academia and they justify this choice with saying something like, I really love this job, but I'm not willing to sacrifice everything to pursue a career in academia. A senior in academia once told me that the system is good as it is because then there is a natural selection and only people that really want it get to pursue a career in academia. I strongly disagree, and I think that we should ask ourselves if we are really okay with washing out all this diversity, and wouldn't research profit more from having a richer assortment of profiles. So I think that one theme could be to start looking at the person in their entirety. But still, the fact that a dialogue on this is already starting, I think it's a very positive and hopeful sign for scientific communities everywhere.
Do you think it is more difficult for women? Is it why it seems that there are less women than men in physics?
I think it's difficult for everyone. For sure, women are disfavored for physiological reasons. If they want to have a baby, sure the impact is greater on women than men. But I think that the problem of instabilities concerns everyone. Understanding why there are less women than men in physics, it's not so straightforward, and indeed it's, I think, part of a bigger discussion. In my experience, I found that the problem is, I think, already at the societal level, so people do not actually know what a physicist does, and there is a prejudice that it is something for men. So perhaps a solution to this could be to do exactly what we are doing now with this video, going out and telling people what it is that we women in physics do.
Thanks, Maria.
Thank you.